welcome back to The Deep Dive. Today, we're diving into something pretty ambitious. How humanity could, actually live out there among the stars.
Yeah, not just visit, but stay. We're looking at the nuts and bolts, the real science and engineering behind making these incredible journeys sustainable.
Exactly. So our mission for you today is to unpack some of the biggest hurdles. Things like artificial gravity, keeping people alive with, closed systems, and the kind of propulsion we'd need to get anywhere meaningful.
It's about taking these really complex ideas and sort of peeling back the layers, making them accessible. Because the solutions being worked on are genuinely brilliant.
Okay, let's start with maybe the most obvious one for long trips. Gravity. Or rather, the lack of it. What does floating around for months or years actually do to us?
It's not great physically. Your bones lose density, muscles weaken significantly. Think about a trip to Mars, 6 months, maybe longer.
Right.
That's a long time to be weightless.
Right. It sounds like a fundamental problem. So, how do we fix it? I mean, artificial gravity feels like something straight out of Star Trek.
Well, it might sound like sci-fi, but the most practical idea is actually based on pretty simple physics. Rotation.
Rotation? How does that work?
Imagine a big structure, maybe like an enormous ring, spinning in space, like a giant, carefully balanced merry-go-round.
Okay.
As it spins, everything inside gets pushed outwards. That outward push is centrifugal force, and if you get the size and speed right, it feels just like gravity.
Ah, so it simulates gravity, sort of tricks your body.
Exactly. It tricks the body into feeling weight, so you could walk, sleep, exercise, basically live as if you had gravity. It helps keep astronauts healthy, maintains that bone density and muscle mass.
Are there downsides? Does it feel weird?
There can be some subtle effects, yeah. Like Coriolis effect, quick movements might feel a little off, especially in smaller rotating sections.
Yeah.
But it's an engineering challenge we think is solvable with smart design.
Okay, so we've got our feet on the ground, so to speak. But what about just staying alive? Food, water, air, out in deep space. There's no corner store, no atmosphere.
Right. That's the next massive challenge.
Yeah.
And the answer lies in what we call closed-loop life support systems.
Closed loop, meaning everything gets reused.
Precisely. Think of it as building a tiny, super-efficient Earth inside the spaceship. Nothing gets thrown away if you can help it.
Okay, give me some examples, like air.
So the carbon dioxide you breathe out, it gets scrubbed from the air, chemically processed, and turned back into oxygen.
Wow. And water.
Water is even more critical. We need systems that can purify and recycle all water from breath, humidity, sweat, even urine. The goal is getting recovery rates up towards like 98%.
Okay, that's not impressive. What about waste and food?
Yep, even waste becomes a resource. It can be processed in bioreactors to break it down and extract nutrients. And those nutrients, they can help grow food.
So you'd have guardians on board.
Absolutely. Advanced hydroponics, maybe aeroponics, smart gardening systems. Plants are amazing because they don't just provide fresh food, which is huge for morale too, but they also help purify the air and manage humidity. It becomes a self-sustaining little ecosystem.
A mini Earth. That's incredible.
Yeah.
Okay, so we can live, we have gravity, but how do we get anywhere? Traditional rockets are great for getting off Earth, but deep space, journeys would take forever.
Exactly. Chemical rockets just don't have the efficiency, the oomph for really long trips carrying lots of mass. We need a propulsion revolution.
A revolution? What does that look like?
We're talking about advanced concepts. Things like plasma engines, for instance. One example people might have heard of is Vasimer.
Vasimer? What's that?
Variable specific impulse magnetoplasma rocket. It's a bit of a mouthful, I know. But basically, instead of a big chemical burn, it uses radio waves to heat gas into incredibly hot plasma, then magnetic fields to shoot that plasma out the back at super high speeds.
So faster exhaust means more efficient propulsion.
Immensely more efficient over the long haul. It provides less immediate thrust than a chemical rocket, but it can keep thrusting for months, even years, constantly accelerating. It gets vastly more miles per gallon, so to speak. This could cut months off a trip to Mars.
Wow. Any other contenders?
Oh yeah, nuclear propulsion is another major area. Either nuclear thermal, using a reactor to heat propellant, or maybe even nuclear electric, where the reactor powers an electric engine like Vasimer. These offer huge gains in efficiency and power.
So faster travel, heavier ships, it really opens things up.
It turns missions that were just dreams into actual possibilities. We could send bigger habitats, more equipment, faster.
So when you put all three of these pieces together, the artificial gravity, the closed-loop life support, and these revolutionary propulsion systems, it's a total game changer.
It really is. We're not just building a transport anymore. We're talking about creating a true home for humanity in space,
Hmm.
a self-sufficient outpost capable of taking us on these incredibly long journeys.
It's more than just a machine, then.
Much more. It's like a little bubble of Earth, engineered to sustain us as we venture out. It's this amazing blend of science, engineering, and honestly, imagination. It pushes us all to think bigger, to see ourselves as cosmic explorers.
So as we wrap up, think about this. What does it truly mean for us, for humanity, to have the capability to live sustainably far beyond our home planet? These aren't just technical problems we're solving. They're paving the way for our future out there, redefining our place in the universe, something to really mull over.